welcome back to Civil Engineering 24/7 YouTube channel. This is Adnan Member and welcome back to today's video lecture of design of compressive strength in design of steel structure. Okay, so in today's first module we are going to solve the problem of the first problem in design of compression member. Okay, let us see. Determine the axial load capacity of column. It is asking the axial load capacity. What is axial load capacity? Suppose this is a column and there is some load acting like this. Okay, that determine the axial load capacity of column ISHB section which is given in steel tables. Carry on steel table students. Okay, so ISHB 300 at the rate of 577 Newton per meter. If the length of column is 3 meters, length of column दे दिया गया है, मतलब column की लंबाई दी गई है, वो कितनी है? That is how much? It is 3 meters. Okay, it is given and it's both ends pinned. It means both ends are pinned. Okay, like this. The section is both ends pinned. Okay, so you can find this pinned section in your steel tables. Steel tables and IS 800 2007 is very important, guys. So first let us move towards the problem. Okay, so the question is determine the axial load capacity of column ISHB 300 at the rate of 577 Newton per meter if the length of the column is 3 meters and it's both end pinned. Okay, this ISHB, it is located in your rolled steel sections of steel tables. Okay, rolled steel sections. So first let us write always the given data. First of all, whenever you are going to start the problem, please open up with your given data. Okay, let us write the given data. We don't know any given data here. We need to assume the given data here always. For FU is nothing but your ultimate stress. Fi is your yield stress. Nothing there, but you need to remember always that there are some minimum basic standards for this all things. So first of all, let us move towards Fy. Fy is nothing but your yield stress. What is your Fy? It is always 250 Newton per m square. Okay, this is your Fy. Next we go for Fu. Okay, Fu, that is your ultimate stress. Ultimate stress is always your like near about 410 Newton per mm square. Okay, 410 Newton per mm square. Okay, so this both is very important. Always at the starting of the problem, write the yield stress and ultimate stress value before start of the problem. Okay, then you got the Fu value, and again we have some yield. This one E is equal to, that is Young's model, 2 into 10 power 5 Newton per mm square. Okay, these three values you got. You know Fi, Fu, E. You need to write Fu, Fi, E. Okay, for the problem solving. Then for we are going to calculate for length of the column is 3 meters. Length is given. How much length is given? About 3 meters. Length L is given. Okay, it is your 3 meters, which is nothing but 3000 mm. Okay, always convert the meters to mm. Okay, that is 3 मीटर से 3000 mm को आपको कन्वर्ट करना होगा. ठीक है, आपने कन्वर्ट कर दिया है 3 मीटर कॉलम को 3000 mm में. ओके, mm में अगर कन्वर्ट किया जाए तो 3000 mm आपका आंसर है. Okay, next we are going for height. This is height or length, you can say it anything. Okay, height or length. Okay, next we are going for this is sectional properties. Sectional properties, from where you will find the sectional properties? From steel tables. Okay, steel tables Falcon की है, Radiant की है, डिप्लोमा में जो आपने इस्तेमाल की थी, the books which you have used of steel tables in your diploma and BTech like Radiant and Falcon, you can going to find the sectional properties for the ISHB 300 at the rate of 577 Newton per meter. तो इसके sectional properties, जैसे कि sectional properties का मतलब अब इसकी breadth of flange हमें निकालना है. breadth of flange. Okay, we need to take out the thickness of web, thickness of flange. Okay, and height. All things are mentioned in your steel tables. Okay, copy down this. I am going to rub this. I hope you copied down this. You have copied down and you have noted down this. Okay, guys. Okay, now we'll fastly go for the sectional properties. Sectional properties मतलब section के properties. अब ये I section है, इसी के properties मैं आप plot कर रहा हूँ from steel tables. I am going to plot the values of BF, TF. Before going for that small dot, sorry guys, before going towards that, you need to find the condition which is given here. That is nothing but both ends are pinned. So for both end pinned, we have one formula there, like it is KL value. We have KL value is equal to, that is how much? 1.0 L. Okay, it is mentioned in your IS 800 2007. Okay, IS 800 2007. You can find it there. Okay, in IS 800 2007, I have explained you in before procedure page number. It is available. So KL value you got 1. So how much is the column? 3. So 3 into 1. Okay, 3 into 1, it is your 3. Okay, it is 3. You got your KL value as 3. Okay, you got your KL value 3. Okay, now note it down, guys. Okay, I hope you noted down this one. Okay, now we will go for sectional properties finally. Okay, we will go for the sectional properties. Okay, now for sectional properties, what we need to get? We need to get the breadth of the flange. So in my steel tables, मेरे स्टील टेबल्स में इसकी ब्रेड्थ ऑफ द फ्लैंज दी गई है. स्टील टेबल्स आप एक बार बुक खोलिए, उसमें मिल जाएगा. ब्रेड्थ ऑफ द फ्लैंज आप इसमें दी गई है नियर अबाउट ब्रेड्थ ऑफ द फ्लैंज. BF मतलब इट इज द ब्रेड्थ ऑफ द फ्लैंज. इट इज 350 mm. ओके, 350 mm. ओके, 350 mm is the breadth of the flange. Now we are going towards the thickness of the flange. Thickness of the flange. That is how much in my steel tables given. It is given about 10.6 mm. Okay, 10.6 mm. 10.6 mm is the thickness of the flange. Okay, now we are going towards the we got breadth and thickness of the flange. Okay, finally now we got the sectional properties. That's it, completed here. Till here we got the sectional properties. We know the height is 300 mm. Okay, now after sectional properties we are going towards from SP1. From SP you need to open from SP1 steel tables. You also get the value of R minimum, that is your least radius of gyration, is equal to RYY. That is how much? It is near about 54.1 mm. Okay, if you watch out in your steel tables, it is the value of 54.11. Okay, here sectional properties completed. Now firstly, next let's move towards the according to table number 10. Okay, after this you need to go to table 10 in your IS 800 2007. Please copy down this. Okay, now wait a minute. According to table 10 in table number 10 in 800 2007 code book. Okay, in your 800 2007 IS code book you have some value of H by BF. You need to find out the H by BF. What is your H? H value is 3, right? H by BF. So let me calculate here. 3 by, you know the breadth of your flange already, that is your 350. So if you do 3 by 350, you get some value 300 by 350. You get some value of near about some value. Then you get some value like 1.2 mm. I have calculated. I got the value of 1.2. Okay. Then what you need to do this value? After getting the value of 1.2 mm, you need to check whether the thickness is correctly matching. No, because you need to check this whether it is satisfying or not. Okay, then after that you are going towards, okay, you completed this one, H by BF 300 by 350, you got 1.2. then you need to check the thickness 40. It should be 40 should be greater than the thickness, then the condition will be satisfied. Okay, we completed the sectional properties. Now we are going towards design compression. Next step, design compressive strength. Okay, we need to write like this: design compressive strength. After that, we know what is design compressive strength formula, right? That is your PD is equal to AE into FCD. Okay, area into compressive strength. Okay, PD axial load. Okay, PD design compressive strength. You know the formula. Then what is there here? Some twist. You don't know this, right? Then you need to go for FCD value. Where you will find this all things? FCD, this you will find in your code book. These equations you will find in your code book, page number 34. Okay, in page number 34, IS 800 2007, you find these equations. PD is equal to AE into FCD. Then for FCD, we have one more formula. What is the formula for FCD? Just hang on, guys. Okay. Now for FCD we have one formula. FCD is equal to, what is that formula? Fy divided by gamma m naught divided by phi plus phi square minus lambda square. Okay, this exactly you will find this formula in your code book. Okay, then for finding your gamma, for finding your phi, you have one more formula. I will write it down here. Okay, see. Then for finding out phi, we have one more formula, 0.5 1 plus alpha of lambda minus 0.2 plus lambda square. Okay, this is your first equation, this is your second equation. Okay, this is your first equation, this is your second equation. Okay, so these two formulas, after that two formulas we are having for lambda, again we are having one more formula here. What is that for lambda? Okay, lambda is equal to, let me write it down here. Lambda is equal to under root of Fy by FCC. Okay, these are the formulas. Now you will solve for these formulas, this first formula, second formula and third formula. For lambda is equal to under root of Fy by FCC. Okay, you know Fy value. What was the Fy value? I said you already just before while writing the given data. That is nothing but 250 divided by FCC. How you will find FCC? For FCC again there is a formula. Okay, I will write it down here. Okay, FCC is equal to pi square e by KL by R square. Okay, KL by R square. No need to worry about this. These formulas are available in your IS 800 2007 page number 34. You can find and write. That's why I am not writing here very neatly. Okay, but you will understand, right, what is the procedure and how to solve everything. Okay, then you know FCC formula. After knowing the FCC formula, finally we should go for buckling class B. Buckling class B, you know buckling class B. Okay, buckling class B. That is your alpha is equal to 0.34. Alpha value, you got alpha value also finally. Okay, you got alpha value, buckling class B 0.34 in your IS 800 2007. Buckling classes for imperfection factor. Alpha is nothing but your imperfection factor. What is imperfection factor? The length is not standard. I mean the length is unequal. Then that is your imperfection factor indicated with alpha. Alpha से इंडिकेट किया जाता है imperfection factor को. ठीक है, तो यहाँ तक हमारा प्रोसीजर हो गया है. आपको यहाँ फॉर्मूलाज में लिख दे रहा हूँ, लेकिन कोड बुक में आपको फॉर्मूलाज अवेलेबल हैं. आप फॉर्मूलाज देख के लिख सकते हैं और आप याद भी रख सकते हैं अगर आपको चाहिए. अगर आप याद नहीं रख सकते हैं तो IS 800 2007 में पेज नंबर 34 जब आप खोलेंगे तो उसमें कोड बुक में आपको ये फॉर्मूलाज मिलेंगे. इसमें आप FCC, PD, FCD, phi और लैम्डा की वैल्यू को आराम से सॉल्व कर पाएंगे. ठीक है, तो हमें ये मिल गया है सारे फॉर्मूलाज. हम अब नाउ वी नीड टू सब्स्टिट्यूट ऑल द फॉर्मूलाज इन इक्वेशंस. ओके, सो I am going to solve here the first equation. Okay, the first equation, what is that? FCD is equal to Fy by gamma m naught. Fy by gamma m naught. Gamma m naught is your 1.10. Always it is constant. Okay, 1.10. Remember. Okay, Fy. What is Fy now? Let me write here 250 divided by 1.10 divided by, you know what is phi? You don't. Oh, you know phi. For phi there is a formula, right? 0.5 plus 1. You need to solve here first that. Okay, so 0.5 again 1 plus alpha value. I got the alpha value here, right? See here, I got the alpha value from steel tables. So 0.34. क्योंकि हमको उसके बाद phi की वैल्यू को सब्स्टिट्यूट करना है, जो phi के लिए हमें वैल्यू मालूम नहीं है, इसकी वजह से phi का फार्मूला यहाँ पे मैं phi के फार्मूले के ऊपर इसको सब्स्टिट्यूट कर रहा हूँ, इसको वैल्यूज में. ठीक है, 0.34 ऑफ गामा. अब गामा को भी सॉल्व करना है. गामा हमने सॉल्व नहीं किया था. फर्स्ट गामा में हम देख लेते हैं Fy by FCC. Fy by FCC का हमें देखना है यहाँ पे. ठीक है, Fy by FCC को सॉल्व अगर हम करें तो इसमें हमें आंसर आएगा सपोज 250 डिवाइडेड बाय FCC. FCC के लिए हमें यहाँ फिर से वापस यहाँ आना पड़ेगा, ठीक है। अगेन वी नीड टू कम बैक हियर, पाई स्क्वायर ई क्या, ई की वैल्यू कितनी थी मैंने बताई थी, 2 into 10 power 5, 2 into 10 power 5 डिवाइडेड बाई KL की वैल्यू कितनी थी, 1 थी ना। हम जब KL की वैल्यू 1 थी, 1 डिवाइडेड बाई और की वैल्यू कितनी थी, लीस्ट रेडियस ऑफ gyration आई हैव सेड यू ऑलरेडी इट इज 54.1। तो जब आप सॉल्व करेंगे तो FCC की वैल्यू आपको टोटल आएगी 641.92, ओके। यहां पे लिख रहा हूं मैं 641.92 न्यूटन पर mm square. You get the value if you solve this equation here, okay. You get the FCC value finally. You got the FCC value. Now you know the FCC value, right? So FCC यहाँ पर मैंने मुझे कितना 641.92 FCC का वैल्यू आ गया है, कितना 641.92, okay. I have written this. Now just directly do the under root. You get some answer, okay. You get some answer. Supposedly, approximately, you got some answer of FCC. You got some answer of suppose you got some answer of 300.2, like that, okay. Then after getting that answer, you got 300.2. Just directly place here 300.2 minus 0.2 plus this how much again, 300.2 whole square, okay. Then you got some phi value. How much you got? Substitute this all values. You got all values. Suppose you got some values of 444, then 444, then finally you have all the values now finally, okay. Now phi value कितनी है, 444 plus ये देखिए plus under again 444 whole square minus हमें लैम्डा की वैल्यू कितनी आई थी, लैम्डा की वैल्यू हमको आई थी नियर अबाउट 300.2. we got the lambda value. Again we have FCD, we got total FCD formula here. Now we got FCD value. Suppose this is not a calculated value, I am just writing for example. Suppose you have 255 Newton per mm square, you got the FCC value, okay. Newton per mm square, 255 Newton per mm square. Now finally what you are left over with, only your design compressive strength, okay. Now you know everything, finished. Now last step is your design compressive strength. I will show you. Of course it is a long video of design of steel structure section, okay, but you people will be बहुत आसानी हो जाएगी सबको, ठीक है. Then what is the formula for design compressive strength? Final formula PD, ये final step है. This is the final step of problem. PD is equal to AC or AE is equal to FCD, okay. So where you will get the value of AC or AE? You will get in the value of AE near about 7484 mm square in your steel tables, okay. Steel tables you will get you this formula, this value for AC for the section of I section. For ISMP 300 you can find the cross sectional area. That cross sectional area is 7484 mm square in your steel tables. So now finally we substitute it, okay. Now finally we are going to substitute this, okay. So 7484 into FCD value, AC into FCD है ना formula. So in this formula what is the value, final value, you got 255, right. So 255, 7484 into 255, suppose you got some value of 10176 newtons. This is your final. So your PD, your design compressive strength is 10176 newtons, okay. This is your final formula. The problem completes here, okay. This was your final formula and your problem is completed here with full of the procedures. So the procedure is explained in before module of this section. This was the problem solving. If there is axial loading and there is section given and there is a condition both and fixed and the height is 3 meters. So this was the rolled section problem on design compression member. So I hope everyone understood the problem very easily. I hope you got the problem, students. Spread the problem across the all students who are facing confusion in this subject. Again I will meet you in the next session, guys. Until then, Allah Hafiz. Wait for the next section and module, and please subscribe Civil Engineering 24/7 for more insightful videos and informative videos throughout the section, okay. Allah Hafiz.